So we've just aligned the probes. We align the calibration substrate. Actually, the probes are aligned against the calibration substrate. We are sure, pretty confident that we can go and move to the any of calibration standards, and looks like we are pretty ready to go for our first calibration project. How do we do it? So Sentio, what you can see from the screen is we have a dashboard which shows us the current status of the system, and what we can read from the dashboard is that the chuck is currently located under the scope, and this is our auxiliary chuck where we have our calibration substrate rated. On the right hand side we have a set of the tools. The carousel menu for different tools is wafer map. Then we have a vision system where we observe our probes, and we see that we are currently over the load standard. Then we have an auxiliary side management module which helps us to navigate across the calibration substrate. That is the part which is embedded in Sentio, and it makes the automated calibration extremely easy and very helpful if you want to move from one standard to another or to check the lifetime of the standard, and I will show you how to do it a little bit later. We have a widget of Calibria and some other widgets here at the carousel menu. All right, let us go and activate Calibria widget and start the first calibration setup. On the Calibria graphical user interface, this is again also a dashboard. Now we are focused on the calibration task. That is why you have everything what is related and important for the calibration, this particular calibration task, and nothing else that can distract your attention. We have the calibration player, just a single button, which helps us to execute the calibration process as a measurement of one standard after another, depending upon what type of the calibration method we've selected here. We have a widget which gives us a snapshot of the current settings of the network analyzer. This is ZNA 67 GHz full plot VNA that we currently have hooked with our system, and it's configured for port 1, port 2 measurements, where port 1 is on the left hand side and the port 2 on the right hand side. That is pretty much the initial setup of Calibria graphical user interface, and it helps you just to see what you currently have and make sure that the current settings, this is out of the box settings, are the same what you really have on your system. I already see one mismatch in the setup. We have Titan 125 micron pitch probes, and the system is currently configured for Titan 100 micron pitch probes. So I need to change the type of the probe and the ball. Just click on the widget of the probes, and you're immediately led to another settings window, another widget, which helps us to reconfigure the probes, where you have a current configuration zoomed in, and we have a list of recently used probes. Usually on one setup, you change maybe 2 or 3 different types of the probes because you measure almost the same type of devices with the same pitch. That's why Calibria gives you already 4 recently used configurations. You don't need to go very deep in details, just switch to one of the possible configurations of the probe, just clicking on one of these recent configurations. I don't see any 125 micron pitch probes on this list, so I need to go a little bit more in depth and details. So I click the button, the gear settings, and we have here the list of different types of the probes. So the family Titan, I have a Titan probes on my setup, ground signal ground configuration, and 125 micron pitch. So I change it here, and I go back, and what we can see is that the probe configuration changed. It changes the models of calibration standards we use for the calibration, like open capacitance, low inductance, and short inductance, because every probe has a slightly different set of these coefficients. It doesn't change models for the transmission lines, because transmission lines, electrical characteristics depend on the design of the calibration substrate, and we use the same calibration substrate, which is AC2 version 2. Well, probes are configured. Let us go back to the dashboard of Calibria, and again, the snapshot of our current system configuration, AC2 V2 calibration substrate, Titan probes, port 1, port 2 connected to the vector network analyzer, and 125 micron pitch probes. We would like to do the use TMRR. This is proprietary MPI calibration method to calibrate the system. Frequency range of our measurements will be up to 67 gigahertz. This is the maximum frequency range that VNA can sweep to, and looks like we are pretty ready to go. So to initiate the calibration process, we simply execute the calibration player. We hit the button, and now we are guided into the calibration player. And here, again, your focus is attracted to anything you need to know about the current task. Task is to calibrate the system. When we calibrate the system, we go over the multiple measurements of different calibration standards. We have the calibration standard list here on the right, on the left-hand side. This is through, this is the load, this is the open, and this is the short calibration standard. And we execute it by the standard playlist. Then we have a widget that controls network analyzer and it controls the prop system. If we go over the calibration measurements in the manual mode, means that we move to every individual calibration standard manually, so we can navigate to the selected calibration standard, like moving to the through, moving to the load, moving to the open, to the short, from this widget, and we can trigger the measurement procedure. So, next widget controls the calibration computation. That is currently the widget which is currently configured for through match reflect. From this widget, once all the data are collected, we can compute error terms. We can define the name of the error set, and after error set name is defined and error terms are computed, we push them to the network analyzer memory by send to the VNA. So also TMRR has an additional capability for so-called self-verification. This is when we look into some additional data measured during the calibration process and make sure if the calibration was consistent and good enough and can be used for the further measurements of a device under test. And last but not least, we have another settings for so-called golden verification. This is the possibility that Calibria gives to any operator to measure well-known devices after the calibration process is complete and compare measured results with predefined parameters from the database and make sure that possible calibration errors are within the margins which are initially defined. And we will have a little bit more detailed look into that feature as well. So, let me demonstrate you how you can manually trigger the calibration process and move from one standard to another standard and check also the consistency of the measurement results acquired by the system on a particular calibration standard. Consistency of the measurement data are important because they are the key of the successful calibration procedure. So if the data are not consistent, if the data are not repeatable, or if data are prompted by some mistake, then your calibration will fail. And you will need to go back to the very beginning of the calibration process, remeasure calibration standards, debug, and trying to understand what exactly happened. Calibria helps you to fix this type of the errors at the very beginning, at the very point when such possible errors happened, and we will be reviewing how it's all actually executed during the calibration process. So, the calibration procedure is currently configured in the manual mode. That's what we can see here and read from the screen. It's just a finger, means that the calibration process will be executed manually. And before I go and measure calibration standards, I really would like to tell to the system which standard I think are good to be used for the calibration process. How do we do it? It's a visual inspection of the quality of the calibration standard. I have a calibration substrate here on my system, which has been used a couple of times. Some of the standards are not in the best conditions, so I would like to verify what is the quality of such a standard and select the ones which are better and which look more or less new. To do it, we have a quick access for the navigation tool. This is Accelerate module, which helps us to navigate across the calibration substrate, and also vision. And you can easily switch between three of these functionalities at any time just by clicking on each of these widgets. So currently I am over the load standard, which is selected to be my local home element, and this is how this load standard looks like. Let me check about the next calibration standard. So I select here the functionality move to calibration standard, and this is the load. And so if I moved here, this is another load standard, and it looks actually, if I have a look on the screen, It's been used a couple of times, but looks like the standard is still of a very good quality, and if I select it for the calibration process, I should have a successful calibration results. How to do it? The selection of the calibration standard can be executed through this navigator tool. So just simply change the tool for used for the cal, not move to, but used for the cal. And after that, I've just click on this calibration standard, and you see a kind of a red circle around the standard. It's a marker that shows us that this particular standard will be taken for the calibration process. So let me double check for the quality of, say, a short standard from the same column. It looks like the short had several touches already. It was heavily used. How about the next one from the line? Oh, this is a very good shot. I actually like it. So that's why let us use it for the calibration process. We are currently over this element, used for the cal. Now we selected this calibration standard for the calibration process. So how about the open? This open looks not good. I actually looks like this open experienced some damages here, which means that what I can do here, not to be confused and any next time I move to this calibration standard, I would like to set the lifetime of this particular open standard to 0, means that I cannot use it anymore. It's on the end of its life. So that's the selected standard, and I would like to mark it as a bad standard. You see, now it's removed completely from the map, which means that it will not be considered for any other calibration attempts. So we simply remove it from the list of all available calibration standard, and it's disappeared from our map. Okay, then move to next one. So how's the neighbor? What's the status of the neighbor? Oh, this is the brand new standard. Actually looks very good. We can definitely use it for the calibration process. Used for the cal. Yeah. And the last standard is the through. So how about this through from the same column? Well, it's been used a couple of times. Let us check for the neighbor. This through element seems to be good. So we can also use it for the calibration process, used for the cal. And well, now we have a list of the selected standards that will be used for the calibration process through, load, short, and the open standard. And we have everything defined, what we want to be defined for the calibration process. And based on the list of the selected standards, they're all displayed here. So we will be measuring through, match, open, and the short, and these will be the standards which we currently selected, and we can monitor it during the execution process. Okay, now let us move to the first standard. I've selected the through standard, move to the through manually, go to the contact, I'll land the probes in the contact, and I trigger the measurement process by simply clicking on the Smith chart of the VNA widget. By doing that, we will measure two different types of the quantities. First of all, we will look into the repeatability of our measurements, and Calibria does repeatability data verification on a different sweep, different to the main sweep. We check data repeatability on less number of points, and the sweep can be configured to any different stop and start frequency points to the main sweep. So we move to the through calibration standard, and let us trigger and measure the data. Before acquiring raw data of calibration standard, Calibria also checks for the data repeatability. And we use a special sweep for the data repeatability, which is a different number of frequency points. Usually you need just few frequency points, like 10 or so, just to understand if the data are repeatable or not. And it can be set for the different frequency lists. Because if your data are not repeatable, they are same unrepeatable on the the whole frequency list or just a shortened frequency list. And this is exactly what we've just evaluated on this particular test. what we observe here is that results of the repeatability test, this is the magnitude difference between the reference sweep, which was the first one, and the 5 other sweeps that Calibria took on the same calibration standard, on the same through, with just 10 points, frequency points, and we see that the all repeatability data are within the margins that we set up for this type of the measurements, which is plus minus 0.01 dB. It's a very stable, repeatable data. We can conclude that the contact is good, and the data measured of this calibration standard will be consistent. So after data repeatability are verified, Calibria moves to the measurements of the entire data set, so the full sweep from start to the stop and all the frequency points, and the frequency range for our calibration project, which is from 50 to 500 megahertz to 67 gigahertz. And we also verify quality of the data. There are several criteria that can be set up for the raw data to understand if your contact was good and if your standard is of a good quality, such as the maximum value of the return loss or the maximum value of the insertion loss of the transmission standards and some other specific criteria. What we currently observe on the screen is that return loss of the through measured S11 and S22 and predefined boundaries for acceptable data results. So we assume that for this particular system, or this configuration, the return loss of the through standard should be slightly better than 20 dB negative at the low frequency range. And our measured data here for S11 and S22 are within this frequency, within this boundary ranges. So the boundary can be adjusted at any time. Well, usually this is an operation which we suggest to do by an experienced engineer who really understands all specifics of the current setup. And once these boundaries are adjusted, they're saved in Calibria project, and any unexperienced operator can rely on this data verification process. So if something is wrong with the data, Calibria will bring a notification that the data are not good, so you need to fix the problem or call an expert. So it looks like the data are verified here and they are consistent, they're good. So repeatability is constant and the raw data are within the boundary conditions. So we can move to the next standard, which is the load. So move to the load standard. We move to the load standard. We go to the contact and we can currently observe that we are really over the load standard. You see how easy it is to switch between different windows, different navigations. So now we are over the load standard. We know exactly where we are. That is our current location. And so the navigator shows us exactly where we are, and we can switch to the calibration processes anytime. You're not distracted by any other unnecessary functionality of the software which are not related to the current task. Well, we are in contact. We can acquire measurement data. Let us wait a little bit. So we trigger the measurements, and Calibria will acquire the data on the load standard, checking repeatability first, and then measuring the raw data. What we can see is that the repeatability data passed. It's a very good example where I can show you how to adjust the boundaries for the pass and fail criteria on the particular calibration standard. So one more time. From the widget that controls the measurements, we have an access to the repeatability of the data. Imagine here we set up pretty tough boundaries for the repeatability pass-fail criteria. This is 0.01 dB. It's measurements deviations from the reference measurement, the first sweep, and all other sweeps that we measured on the particular standard. And keep in mind that the deviations are relatively big because we look into the very small differences of the very, very small numbers. When we measure uncalibrated data on the load, usually we operate with the quantities which are extremely, extremely small. And they're still within the predefined boundaries, which is a good sign. And the raw data, when we have a good impedance matching conditions on the load standard, our return loss on the load should be better than the 20 dB. Here, we have initial settings which were configured for some other measurement conditions. So let us reconfigure them. So we measured the data on the load standard and we adjusted the boundaries for the load standard. Everything is as it should actually be. Let us move to the next standard, which is an open standard. Then go to the contact, measure. So repeatability of the measurement data is perfect. Raw data are within the defined boundaries. So it's all great. The last standard we want to do is the short standard. Move to the short standard, go to contact, and measure. When we measure raw data on the short, usually it's very difficult to prove that you have a good reliable contact. Calibria has a very special algorithm that looks into the raw data measured on the short standard and defines if you have a reliable contact on the short standard or not. So, and we will talk about it a little bit more in the details. So again, repeatability of the data are just perfect. Raw data are great, so we see that the magnitude is within the predefined boundaries, and even the special algorithm tells us that we have a very good results for data for the short standard. They can be used for the calibration process. So now, after we acquired all the data, we can compute error terms and define error set name, push it to the network analyzer, and the calibration process is complete.